So actually, I started explaining about no ensembling techniques, right? From that one, bagging, boosting, stacking. There are three different type of ensembling techniques we have it. So from that one, the first one is the bagging. I already explained about the bagging technology. Bagging is the parallel processing or else parallel modeling. So which means that you might have the n number of data sets. Okay. So you might have the n number of n number of models, and we need to train that all models, and the results we can aggregate. So bootstrap sampling data what we have it, and with the help of that particular subsets we can train the base models, and the results of those things we can bagging. Okay, or we can do that voting or averaging. Okay, that is the bagging concept. So this base model, this bootstrapped model 1, bootstrapped model, or model 1, model 2, model 3, these are the base models. This base models we can create with help of the Navi base or else decision trees or KNN. Oh, someone joined with Sweta. Sweta, actually your session of the Python next 40 minutes, right, but you joined now only. It's different session. It was the high level machine learning concept, like so machine learnings of decision trees and assembling techniques. You're not part of this class.
It is not statistics, machine learning statistics.
Statistics I was not started, right? I'm not I couldn't fix the time. Okay, so next week onwards I would like to go for start the statistics. Clear?
Okay, sir.
Yeah.
Okay, sorry, sir.
Yeah, no problem, no problem. Okay. So this base models, model 1, model 2, model 3, these are the models we can build with help of the different other other models like Navi base, KNN, support vector missions. Okay. And boosting in the sense it could be the sequential model. That means one model results from that particular one model results. Okay, we would like to be boost our weak learning from the previous model. Boosting is the iterative technique that adjusts the weights of the observations depending on the last classification. Okay, you build the model, and from that model you might be getting the positive and negative, right? I mean strong correct results and bad results, right? Good or bad results, right? So the bad results we need to be update those weights, and we can try to be increase the goodness, right? So by starting assigning the equal weights for all observations, then increasing the weights of misclassified, that means wrong predictions, then next iteration, so that the classifier focusing on the observations that are difficulty classifying. So which are the things which are difficulty classify, this classifier will be concentrating on that one. Okay, the final output is a weighted average of the predictions of the all the classifiers. So the most important algorithms like AdaBoost, XGBoost, those are the examples of the boosting techniques. Okay, see, let me see this graph over here. So this is your original data, and with help of the classifier model you build the classification. Some of the things are correct, some of the misclassified. These are the misclassifieds. We're increasing the weights for those things, and again we are classifying it. Okay, for those this misclassified results, and from that one you might be getting the some kind of positive things, again misclassifications, again this misclassifications observations, we have to update the weights of those data, and again we can build the model. And so this is the way every time we are concentrating on the weak learners only. So for the weak learners we are updating the weights, and we are making them into strong learners, from the weak learner to strong learners, right? So this is the XGBoost or boosting technique concept. Okay. Oh, now we have the third type of algorithm, which is the stacking. Stacking is the combination of the both boosting and bagging techniques. Okay, so stacking is the ensembling of the multiple models where each model is trained on the full data set, and then predictions of the all the models used as input to the high level model. That means you can just see that this is your training data. With help of the training data, you build some kind of predictions, you build the model, and so you did some kind of predictions. The same training data with a different model, and you trained it and you build that results, and I mean, you got some kind of prediction for the new things, right? So these are the predictions we are giving input for the another level or another model actually. Okay, so this is the way your constant, or we are combining the both boosting and bagging concepts. Clear? So this is the way the stacking will help you, or combination of the both bagging and boosting techniques, so that we are calling it a stacking. Clear? So this document I can share with you guys. Mhm. Mm. Okay, so let me go for the copying this link, and I would like to be share with you. So you can go and look that document. It could be ensembling document. Okay, so update it. Just click on this one. It will open in the new one. So if you click on that one, you can able to access that thing, right? So don't modify, guys, and we just go and download it. Here we have option file, and download option, we have it, we can download it. Clear? Don't modify anything over here. Any questions regarding about this one, what we are explaining now? So for understanding of this project, I mean, for understanding of this ensembling techniques, I'm come up I'm coming up with one particular project, so that it could be the car evolution project. Okay, so we can able to go for evolute your car actually. Okay, for that one we have a project is random forest. We are going to be using the random forest, that means bagging technique. Okay, so if you click on this one, which is directly going which is redirecting to Kaggle, but if you can download this CSV file, and we can download this Jupyter file. We can access we can access this CSV file into Jupyter file, and we can work on it. Okay, or else we can click on this one, which is redirecting into the your Kaggle. Okay, and then so we can look this particular data set. So here what we can do, we are importing the libraries, important libraries, and we are giving that data where your file is available, and you just look that what could be the shape of it, and then displaying the first five records. And this is the, we don't have any column, but we have a column in our it. So that's, I'm just giving the column names over here, and we are adding the column names to your existing data frame. Then we are just displaying the first five records again, and we're just viewing the summary of the data. Is there any kind of information, is there any kind of object data, is there numerical data, is there everything? It could be object type, so which is not possible this is the data set, it is not suitable for implementing the machine learning, so that we need to be convert this all things into numerical format. Okay, so there are UNACC, there are 15, 12, 20, and AU's AACC 384, and good is 16 and very good is a 65. There is a three, there is a four classes are there. Okay, car evolution. This is the four classes. Okay, and so here data set is not balanced. If the data set is not balanced, then we have a concept of the no upsampling and downsampling, or sampling methods we can use it, or else AUC ROC, with the help of that one we can able to um, fit the model whether it is good or bad. Okay, now declare the features of vectors and target variables. So I'm considering the my y variable is the class. Other than the class variable, everything it could be X data. So you're splitting the data into training part and testing part, and this could be the training part, and 571 it could be testing part actually. So try to be observed here. We have the total records are the total records are the 7 something is there, right? But out of that one, 1210 is there, right? But when you are when you are split your training data, just imagine when you split your training data, 1157 is there. Unfortunately, your all 1157 are the same class. Then what happens? Whatever the model you created, that is not correct, right? Even you are getting the good accuracy because of you are getting the training, you're training the model, and we are getting the class is the UNCC, right? But unfortunately rest of the three things we are not getting the good results. So that is a problem when the data is, when the data set is unbalanced. Okay, so when the data set is unbalanced, make sure that we need to go for the, we need to go for what, we need to go for upsampling or downsampling. And then if all classes count could be the same, then your model can give that good accuracy or good results. So you are applying the ordinal encoder. When you are applying the ordinal encoder, all data can be converting into the numerical format. Once the data is numerical format, then we can able to go for apply the machine learning algorithm. So we are just applying the random forest algorithm, and we are getting the good accuracy 92%. But I'm not sure, because of it was the data set is unbalanced. If the data set is unbalanced, even you're getting the good accuracy score, we cannot say that the model is good. Okay, so for that one, what we can do, that the matrices we have it, those things we will learn in upcoming sessions. So we are just giving that n estimator. That means we are taking the n bootstrapped data. We are creating the n models. When I'm n estimator, that means the data, the random forest base models are 100. So we are creating the model accuracy, which is 97.57. That means the model is giving good accuracy. Previously, for 10 decision trees, we are getting the 92% only, right? But when I am using the 100 decision trees, we are getting the 94 percentage. So your accuracy, it was increased a little bit more. To find the important features, so you need to go for finding the which are the features are important. So from this one, we will able to go finding the important features actually. Okay, so CLF feature important. So we are just taking the important features. So we are creating the CLF, right? Classification is within this one. We have the important features. Is important features variable is there, and we are taking all the columns over here. Okay, and so we are taking the safety, persons buying, meant, and these are the importance. Okay, from this one, 30% could be the safety, and 23% it could be the persons, and buying it could be the 13, and mint it could be the 14, right? And it could be the 10%, right? It could be 7% only, right? Okay, so we can see that most important feature is safety, and the least important feature is doors. So we can neglect the doors feature. So with help of the random forest, we can find, or we can finding the important features as well. Okay, so we're just plotting that based upon the feature score. So safety is giving the high visualization, so that this could be the bar graph, it could be the good. Again, with help of the selected features. So you're not taking the doors, right? So we tell you're dropping the doors as a x variable, and again we are building the model. And when you building the model with 10 estimators, with help of the 10 estimators only, so again we are getting the 92%, right? If we go ahead with confusion matrix, in a confusion matrix, true positive, true negative, false positive, and false negative, there could be like type 1 error and type 2 error. That means actually it's a true, but you are getting the false positive. Actually it's a negative, but you are getting the false positive. Actually false negative occurs when the predict observation does not belong to certain values class. But we figure out very this is very serious error, but it is called type 2 error actually. Okay, there could be some kind of errors, so that errors we are calling it a type 1 error and type 2 error. So you can see this is the true things, this is the true things, this is true things, this is true things, this is wrong predictions, wrong prediction, misclassification, this is misclassification, this is misclassification, this is misclassification, this is also misclassification things. Okay, so this is the confusion matrix which we are giving that 4 by 4 because of we have the 4 multi classification, right? 4 classes, there are 4 classes are there, so that's a multi classification. So we have the classification report. So from here we have the precision and recall and F1 score. With help of this one, we are our model is good or bad. So here F1 score is giving the good thing for all, right? Okay, so based upon this F1 score or precision recall, if it is giving the high value, then I can say that the model is little bit of good. So the conclusion also I made it over here, and we just try to read this one, and this is the way we can able to creating the classification report. Okay, so guys, I uploaded this information in our machine learning library module. Okay, you just click on that one, and we can able to go for accessing, or else we can download the CSV file and we can download the Jupyter file. Okay,
Yeah, the random forest classifier that didn't work last time.
sorry.
The random forest classifier that you uploaded, I tried to, go through the link, but it didn't work.
Now we can click on it. Now we can open it. Random forest classifier.
Okay, let me try.
You can click on it. So here we have an open random forest. You need to click on this one. Okay, then it can open it.
Sure. I hope I see it.
Everyone please do it actually. So this is important. Random forest is the very important algorithm. So without a random forest algorithm, might you cannot see any classification project. Is everyone is working or not this thing?
Yep.
Even if you want to open this file, Ensembling Learning Introduction file, you can click on this one. So previously when I'm uploading by the time I'm not selected the new window. That's the reason we are getting an issue. The canvas which is not accessible inside of it, this files, so that I'm opening with a new window. Okay, if you want to open this kind of files outside of files, make sure that it could be a new window. That's the reason. Clear?
Clear.
Previously you could not able to access, no, but you can access now. That was the class for today, guys, and hopefully you got it everything. And by tomorrow, what we can do, I would like to go for the some kind of XGBoost or else stacking techniques, XGBoost and AdaBoost, those that are related project we will work on it. Okay,
Okay.
bye, take care.
Thank you.